All right, guys, here we are. We're going to be looking at the covariance right now. So the covariance is a metric that allows you to quantify the extent to which two variables are trending on the same direction. Okay, it's a mathematical equation again that allows you to assess if two variables are moving on the same direction or not. I should let you know in advance that the metric by itself, the quantification itself, is not really that useful because it's very difficult to interpret. However, the covariance is something that we use for another metric called the coefficient of correlation that actually is more interesting and easier to quantify. Unfortunately, for you to get there, you need to quantify the covariance. Let's remember, before we get to assess the covariance, let's remember the variance, okay? So if you remember the variance from the last chapter, the variance is simply the sum of squares divided by the sample size. And again, the main intention of the covariance, of the variance, sorry, is to assess the extent to which every point, how far from the mean every point it is. Again, it's an indication of the variability in your data, and all what is intended to do is again to quantify the extent to which every point, how far every point is from the mean. That's what the variance is. The covariance is somewhat related metric in the sense that it's looking at the variance in one variable and how it relates to the variance in another variable. And basically is quantified with the mathematical equation that you see there on the top. So let's not panic for now. We're actually going to see that it's very simple to interpret that index there. Before we begin, let's review the variance. So let's use the data that we used earlier. Again, looking at the hours per week that the students study in my class. Again, we can simply plot that for Peter, Laura, John, Chip, and Tom. We calculate the mean, which you already know. For every one of the students, we can calculate the difference from the time that they studied to the mean. And if you guys remember, those differences is what we plot in the variance. Okay. In theory, I can have a second variable. Imagine that I also collected data on the scores that the students got in my class. How exciting that is. I can be able to figure out if the amount of time that they study is reflected on the scores that they get in my class. So I can take that second variable and I'm going to plot it for the time being on the y-axis. I'm going to do exactly the same thing. I'm going to plot just the data on the scores for every one of the students. I can again calculate the mean for y. And for every student, I can also calculate the difference from their score to the mean, just like I did for the x-axis. It's now that the second variable, I have it located now on the y-axis. Pretty straightforward, right? Again, all what it is again quantifying for every data point the difference between the data point and the mean, and I did that for the x-axis and for the y-axis. Now, what I'm going to do next, I'm going to extrapolate the mean on this plot so that we can appreciate what every point does to the covariance. Let's analyze the first point, the data for Peter, right here on the bottom left. Again, if you look at the difference on the y-axis, is negative, okay? So you can see how Peter is below the mean. As a result, that difference, x minus x mean, is going to be negative, okay? Again, the mean is larger than what Peter got, so by subtracting it, I get a negative score. If I were to do the same thing for the x-axis, again, looking at the difference in time between the time that Peter studied and the mean, that score from Peter is going to be negative. Again, all what I'm doing here is calculating the difference in x for Peter and the difference in y for Peter as well. If you look at the index of the covariance, that's exactly what it's asking you. So I'm going to plug the difference in x and the difference in y. So one of the things that you can see now is that I had a negative times negative. So the contribution of the first point of Peter to the covariance is going to be negative times negative is going to be positive. Isn't that interesting? So Peter is contributing to the covariance positively. Okay, let's now look at the second point, which is the data for Laura. Again, I'm going to calculate the difference in y. In this case, it's negative. I'm going to plug that into my equation right there. I'm going to calculate the difference in y. And again, that's negative because it's to the left of the mean. And again, if I plug that value into the covariance, the effect of Laura to the covariance is negative times negative. So that's positive. Isn't that interesting? Laura as the Peter are contributing to the covariance positively. I'm going to bypass the third point, but let's analyze the 4 point, the data for Chip. Again, I'm going to calculate the difference in X. That's going to be positive because in this case, Chip is to the right of the mean. If I were to calculate the difference in Y, again, in this case, this guy is above the mean, so that difference is also going to be positive, okay? So now if I were to plug these two differences in the covariance, basically I get positive times positive, that will be positive. And again, the same deal will be for the last guy. The difference will be positive, and the difference in y will be also positive. Positive times positive gives you positive. Again, what I want you to understand is that in this case, in this situation where the data points are following that line that is indicated there with the dotted line, on those cases, all of the points along that line contribute positively to the covariance. And that's why the covariance can tell you the general tendency of the points. Basically, are the points trending on the same direction? And on this case, again, when they trend along this dotted line, the covariance will become positive and very large. Okay, again, that's the purpose of the covariance. The only goal of the covariance is just to tell you the direction in which two variables are related to each other. And while the metric itself is not that useful, very hard to interpret, is used later on to assess also how strong that correlation. But for the time being, what I want you to understand is that, again, the covariance is basically looking if the differences in one variable are trending on the same direction that the differences in another variable. Again, let's review very quickly. All of the points that are located to the left of the mean on the x-axis will contribute positively to the score, and all of the ones that are below the mean on the y-axis will also be positive, those differences. So the differences being positive and positive will mean that they will be positive on the coefficient of the covariance. The same deal goes into those points there. Again, they will contribute positively to the covariance. And again, the interesting thing is that every point that follows that general trend will make the covariance positive and larger. The covariance can also be used in the opposite case, and it will give you exactly the same kind of metric, but negative. Let's analyze, for instance, a case of the time that you guys spend looking at Facebook. In this case, I will expect that the students that spend the less time in Facebook are going to score higher in my class because they will have more time to study, as opposed to the students that spend a lot of time in Facebook, and at what time are you going to be doing any work. So in this case, you can see that there is a different trend here. So let's look at what the consequences of these points are to the covariance. Again, can the covariance give you an indication of the trend? And indeed, it can. Let's look at the first point here. You can see in the axis y, this point is above the mean, meaning that the difference will be positive. Okay. Now, if we look at the difference in x, is to the left of the mean. As a result, that difference will be negative. So if we were to add the difference in x and the difference in y to the covariance, negative times positive will give you negative. So that first point there, this point here, will contribute negatively to the covariance, okay? And so it's pretty much any point located on that quadrant there. Let's look at the opposite case, right? In this case, this student is located to the right on the x-axis. As a result, the difference will be positive, right? But it's located below the mean on the y-axis. As a result, the difference will be negative. So again, if we add these differences into the covariance, positive times negative will give you negative. And so will be any point on this box here. So again, when you have data that follows this trend, the covariance, every point will contribute negatively, making the covariance negative and larger. You are adding up a lot of negative values, so the consequence of that is that the covariance will be negative and large. So again, the goal here is for you to comprehend that the index of the covariance, all what it's doing is assessing the extent to which pairs of data are trending on the same direction. And you can see that it doesn't really matter whether it's positive or negative, the covariance can give you an idea of whether those differences are trending on the same direction or not. Again, just to summarize, the main goal of the covariance is to tell you the extent to which data points are trending on the same direction, positively, negatively, or no relationship at all. And again, while the index that you get from the covariance is not useful by itself, it can be used on other metrics like the coefficient of correlation that we will study next, that is actually more intuitive to comprehend. And that's the covariance there for you. Please follow up in the book where you will see case examples to calculate the covariance.